All right, let's do some more exponential growth models. This is an example for finding the rate of growth. According to the United States Census Bureau, the population of Utah was 2.12 million people in 1997 and 2.53 million people 9 years later in 2006. Use an explicit exponential model that is provided to calculate the rate of growth of the population over this time period. Express the rate of growth as a percentage, round to the nearest hundredth of a percent. All right, so let's start off with our exponential growth model. Okay, as we read through this, the population was 2.12 million in 1997. That would be our initial value. 2.53 million, that would be after some growth has happened. 9 years later, that would be the value for n. So we have everything we need to find r. So this would be 2.53 equals 2.12 times parenthesis 1 plus r to the 9. Okay, to solve for r, we're trying to isolate r. We need to just get rid of everything around it. So eventually we'll have to subtract that 1, we'll have to do a root to get rid of the 9th power, and we'll have to divide to get rid of this 2.12. And that's the first step. Divide the coefficient to the right. Now you might want to start doing the arithmetic on your calculator, but I would hesitate on that because you're probably not going to get nice whole number or even non-repeating decimals when you work these problems out. And we can take a look. 2.53 divided by 2.12. Yeah, it's a big messy decimal. And if you wanted to work with that decimal, you have to ask yourself, where should I round? And now when you're rounding, you're now making a mistake. Rounded answers are not exact answers. They're not correct. They're very close to correct, but I want correct answers to the very end and then round once at the end and have the best answer possible. So I am not going to calculate the 2.53 divided by 2.12. Instead, I'm just going to leave it as a fraction, ready to be calculated later. All right, next up, we need to get rid of the 9 power. There's two basic approaches. One is a root, the 9th root. And that's very comfortable for a lot of people because a 9th root gets rid of a 9th power. But you could also raise both sides to the 1/9 power. And then 9 divided by 9 is 1. That works the same way. And in fact, something to the 1/9 power is the same as that something to the 9th root. Well, that didn't work out very well. So I'm just going to use the root, the 9th root, because it's a little more familiar for students. So we now have the 9th root of the fraction 2.53 divided by 2.12 equals 1 plus r. Very close now to solve for r. We subtract 1. On the left side, I would write this the 9th root of the fraction. And then outside of that, a minus 1. That's the exact value for r. That is now something we can calculate. To get the 9th root, you hit the 9 first, then the nth root button. And we now have 9th root. I'm going to use a fraction inside 2.53 over 2.12. And then out of the root, the minus 1. Okay, this is the decimal rate. Now as we look at the instructions, it says express the rate as a percentage. So let's multiply our decimal rate by 100. That is now a percentage. Now we go to round to the nearest hundredth of a percent. So we go to the nearest hundredth. That's the 0.98. To the right of the 8 is a 3. That does not round up, so 1.98. R is approximately 1.98%. To find the rate, use a root. Use a root to find the rate. All right, your turn. Go ahead and pause the video and work out the rate for this exponential situation. All right, you should end up with R is approximately 21.4%. We can check this. We can do this in a couple of ways. Let me show you a couple of approaches to check this. First off, the exponential explicit model. We have P sub 0, parenthesis, 1 plus R. I'm going to do 21.4 divided by 100. 2 N. And we want 7 years later. This should be about 21,000. A little bit less, so I can see that we rounded down to get this R, but that looks great. We could also use the recursive model, starting with the initial population, and then answer times 1 plus R. This time let me use the fraction button, just so you can see different approaches. There's 1 plus R times answer. This will be 1 year later, 2, 3, I'm just hitting enter, 4, 5, 6, and 7. Very close to our 21,000. After the 8th year, we're beyond that. So this is verifying that rate in a couple of different ways. All right, I hope this helps.